In this video, we will do some examples where we find the area between curves. So I want to begin with this example that says, find the area between y equals 12 minus x squared, y equals 3x plus 2, and x equals -1. So to help us visualize this, let's draw a rough picture. So I'm going to draw some axes here. And let's first draw y equals 12 minus x squared. And everything here I think is simple enough where I could draw it without a graphing calculator. So 12 minus x, y equals 12 minus x squared, that is a downward facing parabola. So that would look something like this, downward facing parabola. I know it's a parabola because it's a quadratic. I know it's downward facing because there's a negative coefficient in front of x squared. Okay, and then for y equals 3x plus 2, I know that that graph is a line, and the y-intercept is 2, so somewhere positive, and the slope is also positive, so the line should be going something like this. The line should look something like this. And then I also need to draw x equals -1, which is also a line. But what I don't quite know is x equals -1 like here, or is it on this side? And it can be helpful to know that. So to help me draw a more accurate picture, what I'm going to do is I'm going to look at both of these equations, plug x equals -1 into both of them, and actually, you know what, let me write the equations for both of these. The parabola is y equals 12 minus x squared, and the line was y equals 3x plus 2. Okay, so now coming back to what we were saying before, I'm going to plug in x equals -1 into both of these equations to figure out what the y value is so I can draw a more accurate picture. So plugging in -1 into the parabola equation, we'll get y equals 11. And if I plug it into this line equation, if I plug in x equals -1, we will get y equals -3 plus 2, which is -1. So now I know when I plug in -1 into the line equation, the y value should be negative. So we are looking at like a point over here, say. So when x is -1, the y value here is -1. And on the parabola, the y value is something positive, it's 11. Okay, so x equals -1 looks something like this line. Okay, so we are after the area of this shaded region. We need that area. So looking at my picture, I know what the top function is. It's the parabola. I know the bottom function is the line. I know the left endpoint of my interval. It's -1. But for the right endpoint, I need to know what this intersection point is of the two curves. So let's find the intersection point. In fact, by looking at my picture, I see that the curves are going to intersect twice, but I only care about this right intersection point. So I'll keep that in mind. So to find the intersection point, I can set the two equations equal. So from the first equation, we will get, so let's set 12 minus x squared, that's what y equals in the first equation, equal to 3x plus 2, that's what y equals in the second equation. And I'm setting those two y's equal to each other. All right, so now I can rearrange this to move all the terms to one side. So let's move all the terms to the right to make the x squared term positive. So I'll get positive x squared, I'll get a plus 3x, and then I'll get 2 minus 12, which is minus 10. But now this quadratic factors easily. So we'll get 0 equals, how does it factor? This is x plus 5 times x minus 2. So now I can go ahead and say what x equals. From the first parentheses, we get x equals -5. From the second one, we get x equals 2. And now we know the x values of the two intersection points. Okay, so the one that we care about, this one over here, is happening when x is 5. So we are ready to write our integral. Okay, so let's do this. So our area can be represented as an integral. Let's see, the interval goes from -1 to 2. That's the interval, sorry, not -1 to 2. Actually, you know what, that's right. I mislabeled my point in the picture. This wasn't 5. That point was 2. Right, because my x values were -5 and +2. So this x value of the intersection point I care about was 2. Okay, so just corrected that. Let's go back to our integral. So integral from -1 to 2 of, and then I need the top function. So I'm going to call this y top minus the bottom function, so y bottom, and a subtraction in between them. So our top function was the parabola. So that was y equals 12 minus x squared. And the bottom function, I'm first going to write this deliberately wrong and see if you can spot my mistake. Okay, so the bottom function was the line, which was 3x plus 2, y equals 3x plus 2, and then I needed dx. But this is wrong. Something is wrong about what I just wrote. Pause the video for 20 seconds, just 20 seconds, and see if you can spot what my mistake was. 4, 3, 2, 1, pause that video. Pause it for 20 seconds and see if you can spot that error. All right, so hopefully you did that. The mistake was I forgot to put a parentheses around 3x plus 2. The minus sign means it's got to be minus all of this, the whole 3x plus 2. And if I don't put a parentheses, I'm only subtracting the 3x when I need to be subtracting the whole thing. If I forget that parentheses, I'm going to forget that I need to distribute this negative sign to both of those terms. All right, so let's go ahead and do that next. So we have this integral from -1 to 2, 12 minus x squared. In fact, let's just start to simplify this. Let me keep the negative x squared first. And then I know I'm going to have minus 3x. And then I'll get 12 minus 2, which ends up being positive 10. Okay, so now I can do this antiderivative. And I'll get negative x cubed over 3 minus 3 halves x squared plus 10x. And then vertical line, so I got to plug in 2 and -1 into this. Oops, okay, so first let's plug in 2. If I plug in 2 into this, we'll get -8/3. If I plug 2 into the next term, we'll get -3 halves times 4, which will simplify to -6. And then 2 times 10 is 20. And then minus what I get when I plug in -1. So I'm making sure I put that parentheses. -1 into the first term will give me positive 1/3. Into the next term will give me -3 halves. And then to the final term will give me -10. All right, and if we simplify this, so simplifying this, -6 plus 20 is 14. And then minus -10 will give me a plus 10. So overall 14 plus 10, that's going to be 24. I know from the -3 halves, I'll have plus 3/2. And then finally, when I put the -8/3 together with the -1/3 from distributing the negative sign, we'll get -9/3. Okay, so 9/3, that's 3. So 24 minus 3, that's 21. 21 plus 3 halves. And getting a common denominator, 21 will become 42/2. Multiply top and bottom by 2 to get that. Plus 3 halves. I need a common denominator so I can add these fractions. So on the top I get 45, on the bottom we get 2, and that's our answer. That's the area between these two curves. All right, so let's look at another example now. Let's find the area between y equals x cubed and y equals 2x squared plus 9x minus 18. Okay. All right, so let's see if we can draw a rough sketch here to get us started. Okay, so I'm going to draw some axes. So y-axis and an x-axis. Okay, and the graph of y equals x cubed. So this cubic function looks something like, it gets flat momentarily at the origin, and then it keeps on sort of snaking upwards like that. And then for this quadratic, the graph of that is a parabola. And the positive coefficient in front of the x squared means it's going to be an upward facing parabola. And one thing that can help me know sort of roughly where this parabola is by using the vertex formula to get the x-coordinate of the vertex. So from the vertex formula, we get that x equals negative b over 2a, where the b is the coefficient of x. So we're thinking of this as being in the form ax squared plus bx plus c. So the b is 9, so we'll get negative 9 on top. And a is 2, so we'll get 2 times 2 on the bottom, which is negative 9/4. So that's the x-coordinate of the vertex of this parabola. So I'm going to draw that in. So we'll draw that in. So that's going to be somewhere here-ish. So how did I know that it was below the x-axis and not above? Well, I can see that by noticing what the y-intercept of this parabola is. So the y-intercept we get by setting x equal to 0. If you set x equal to 0, we'd get y equals negative 18. So I know the y-intercept of this parabola needs to be a negative number. So maybe it's there. But that's how I know that this vertex is below the x-axis and not above it. Okay, so now let's draw a rough picture here. So I'm going to start to draw my parabola. Something like this. And before I sort of continue it further, let's just say I kind of keep it here. Because maybe I don't know if this parabola is going to intersect that x cubed function again, or if it's going to go above it. This is where finding intersection points can help me in my drawing. So let's find our intersection points, because that'll help me determine, okay, should I make it cross one more time? So we're going to set these two equations equal. So we'll get x cubed, because both of them equal y, and so we can set them equal. We get x cubed equals 2x squared plus 9x minus 18. Alrighty, and now let's move all the terms over to one side to get x cubed minus 2x squared minus 9x plus 18 equals 0. Alrighty, so with this, I want you to pause the video for 2 minutes to see if you can solve this equation. We've actually reviewed how to solve equations like this, these sort of cubic equations that have 4 terms in a previous video, and this is some review from algebra. But pause the video for about 2 minutes to see if you can do this. 4, 3, 2, 1, pause that video. Pause it for about 2 minutes to try to solve this equation. Alright, so hopefully you did that. Hopefully pause the video for about 2 minutes to really try this. But the key idea is we need to try to factor this by grouping. That's a really common technique to try to factor expressions that have at least 4 terms like this one does. So when we factor this thing by grouping, I'm going to try to group the first 2 terms together and the second 2 terms together. From the first group, I can factor out an x squared and be left with x minus 2. From the second 2 terms, I'm going to factor out a minus 9, because then I'll be left with x minus 2. And I notice that x minus 2 is now common to both of these groups, and that's how I know that the grouping is going to work. So if I factor out that common x minus 2, what I'm left with is x squared from the first group, and then minus 9 from the second group equals 0. And this x squared minus 9 factors, we get x minus 2 times, this is a difference of squares, so x minus 3 times x plus 3 equals 0. So it's factored. Now we can say what x is. X is 2, we also get 3, and negative 3. So in terms of our graph, I can see that there's one x value that's negative where they cross. That's negative 3. I know that the next x value where they cross is 2, and it seems like there's one more x value where they cross. So I need to, let's continue the parabola, and they should cross one more time over here. Okay, so my graph is definitely not to scale, but whatever this x value is, I know that that's supposed to be 3. So that's how finding intersection points can guide me in terms of determining how many times do they cross. So when you do these problems, sometimes if you're unsure about what the graph looks like and unsure specifically about what's the top function and what's the bottom function on some region, what you can do is something similar to what we did in the example, the first example in this video. Notice here, I plugged in a specific x value. I plugged in -1 into both of my functions. So when I plugged it into the parabola function, the y value I got was 11. When I plugged it into the line function, the y value I got was -1. So I could see that 11 is bigger than -1, and that's how I knew that the parabola function was higher up. It was the top function. So similarly, in this problem here, once you know where they intersect, if you wanted to, now we could pick sort of test points in the middle. Like let's say I wanted to pick something like x equals -1, and I could plug that into the cubic function and also into this parabola function to see which one's higher up if I was unsure what's the top function, what's the bottom function. Alrighty, so let's keep going with this example. So what we see now is there are sort of two regions here. There's this first region, I'm going to call this A1, that we need to find the area of. And there's this other region, area 2, which is this region over here that we need to find the area of. But going from area 1 to area 2, the top and the bottom functions switch. So I'm going to need a separate integral for each of those regions. So our area equals A1 plus A2. And remember, as we talked about in the previous video, both of these need to count. They need to count as positive. Okay, so I'm going to need a separate integral for each region. So for A1, my interval would go from -3 to 2, and the top function on that first region is x cubed, and then minus the bottom function on that region is that parabola, 2x squared plus 9x minus 18, and then dx. So the x cubed again was the top function, and then this parabola, this quadratic, was the bottom function. Okay, that's for A1. And then for A2, A2 is on the interval from 2 to 3. And the top function there is the parabola part, 2x squared plus 9x minus 18. And then I need that minus the bottom part is the cubic there, x to the third. Okay, alrighty. So from here, it's not bad at all. For this first integral, we'll get -3 to 2. We distribute that negative sign, and we'll get x cubed minus 2x squared minus 9x plus 18 dx. And the next integral, let's just keep it how it is for now, and then we'll do all the antiderivatives together. So 2 to 3, and then let me just move the x cubed term to the front, minus x cubed plus 2x squared plus 9x minus 18 dx. Now we're ready to do some antiderivatives. This is just a bunch of reverse power rule. So we'll get x to the 4 over 4 minus 2/3 x cubed minus 9/2 x squared plus 18x for that first integral. Okay, and then I'll have to plug in -3 and 2. And then I need to add that to what I get from the second integral. So the antiderivative of that one's going to be really similar. So I'm going to write it quickly. Basically, just all the signs are switched. Minus x to the 4 over 4 plus 2/3 x cubed plus 9/2 x squared minus 18x. Whoops. Let's zoom that out a little bit. Minus 18x. And I have to plug in 2 and 3. So from here, it's just plugging in some numbers, doing some arithmetic and simplifying. So I'm going to skip that stuff. So I'm just going to put this equals ... This some simplification steps. And eventually, this first integral becomes 875 over 12. The next one ends up becoming 11 over 12. When you add these two fractions, we will get 886 over 12. Okay, and then we could divide the top and the bottom by 2 to get 443 over 6. And that is our area. All right, in terms of our goals for this section, we have finished our second goal, which is doing some examples, finding areas between curves. In the next video, we'll discuss how we can find the area between curves when our equations have the form x equals some stuff.